Okay, hello everyone. Okay, this is the weird, a little bit layout. Okay, so let's start. It's a panel discussion. We're going to talk about modern software architecture. I believe let's start with some introduction. Each one will tell about himself, a little bit, where you're from, what you're doing, what you like to do, what you hate in the development. So yeah, let's start with Alberto.
Hi everyone, Alberto Schibal here from Venice, Italy. I've been working as a software engineer for around 8 years. Started in the TypeScript and Node.js land, and then moving on to the Rust and WebAssembly part of tech. Although when all my tests passed the first time, and I kind of hate it when the results on the CI are different than the results on my local laptop. And I'm gonna pass the ball now.
Okay, thanks. And Rick?
Yeah, I'm Rick Marcelis, Principal Quality Consultant at GT in the Netherlands. And I've been in IT for 42 years now. I started off as a programmer and my career did all sorts of things. And the last 5 years, I'm focusing
Sorry, Rick, we have some issue with your internet connection. I'm sorry, we have some technical issues. We have some internet connection.
I'm sorry about that.
Okay, can you try one more time, please? Because we just heard about the 42 years in tech, and it was a little bit, so let's try it one more time, please. Sorry.
I'm sorry about the technical issues. From a technical perspective, I have a 80 megabit connection, so I thought it would be enough. Anyway, I've been a long time in IT, been many different things like programmer, project manager, but last 4 years I'm specializing in questing, and I'm looking towards teams and organizations in implementing built-in quality from the start and focusing on business value, because it's not the IT that's basically what the world is waiting. It is the business value thereafter.
Okay, thanks. And I'll introduce myself. My name is Daniel, and I work at Dell as a senior principal. And I'm more than 20 years. Also, I'm not that young in the development. And I had also quite a long journey from developer HTML, CSS, all the way to sometimes DevOps, sometimes full stack, sometimes many other things. The most thing that I hate about the development is I love everything about the development. So there is sometimes some challenges that make our life, let's say, more interesting as developers. But I do like development. And you know what? I want to start our session with some type of, let's say, how's it called? Sorry, I just got a blackout. Not technical question, but philosophical question. This is the word what I was looking for. Okay, some kind of philosophical question. So I'll start. I will split it. Okay, we had a long time ago the web applications were served mainly by server-side rendering. Okay, and was served as a static HTML content. Then we had all this evolution, single-page application, JavaScript, Ajax, and now we coming back to the server-side rendering again. Okay, we have all these frameworks that we came back to the server-side rendering. The same with the microservices. Back in the few years ago, it was everything about the monoliths. Then we start to build it in part, microservices. And now, more and more, I see the articles about how the monolith can save your time, save your money, and everything like this. Similar to, by the way, cloud. Okay, we all had our own, like most of the companies had their own data centers, or they was renting the place in the data centers, and actually keeping their, the iron hardware. And then everyone moved to the cloud. And now again, I hear more and more articles about, hey, having your own, maybe not everything, not entire infrastructure, but some of it, having in your own data centers can be much cheaper. So my question is about the historical circle. Okay, that everything comes. What do you think? How will looks the next one? How it can affect the architect, the modern software architecture right now?
So Rick, do you want to go first?
Well, like you say, in my career, I have many of these circles and things going and coming back, and yeah, so different. We invent the wheel, but we different. What about action? Because it keeps. You know what? I will switch computers. I'll try to connect from another computer. You continue the discussion, and I'll see you hopefully in a minute, okay?
All right.
Okay, good.
Good luck.
Good luck with that. Okay, so what do you think?
Yeah, so I will definitely agree with you there. There's this trend in tech where every 10 years or even less, we tend to stick to a certain pattern of working, right? And then we see like a rise in blog posts and like tutorials, repositories mirroring that specific pattern. Like you mentioned, that server-side rendering was all the trend, and basically all there was originally. Like I remember when I started in high school, there were like these PHP applications. You would just call you will have basically access to the database and access to the view layer inside in the same part of the code base, right? You will basically have a call here and then immediately render the view here, which is very similar to what, for instance, the Next.js framework has been showing in like I think in the past month or so, with this kind of trying to go back to review the benefits of server-side rendering. And of course, in the middle, you mentioned there was Ajax. I remember like having to use jQuery to support these asynchronous calls to a backend, maybe to REST API or something. And then eventually we had the standard fetch, for instance, in JavaScript, and then we will integrate API calls, maybe in React frameworks or in other JavaScript Vue frameworks. To me, it's always a matter of, there are generational shifts, right? So the people that are mostly working as juniors right now, or like at the mid-level right now, they maybe haven't even seen the previous style of working in tech, right? Or the previous style of working, developing applications. So maybe they're just discovering things they weren't really aware of, and are like, wait, why aren't we doing software development like this? Like, why are we sticking with client rendering, where we need to, maybe we have like larger loading time in the browser before we get like a meaningful paint rendering, or where we also need to support maybe a different REST API just for our project, which might be that small that it's a little bit cumbersome to have, and we might have course issues and whatnot. So to me, it's a matter of every time a bunch of new people join the tech sector, not all of them know about the history of the tech evolution itself. And moreover, the people who do, they probably want to get back the benefits they used to have 10 years ago. Because, for instance, at least for me, full stack development was much easier in terms of time to like create a meaningful application, although maybe it may not be that nice, it might not be that interactive. Whereas right now we have a much better developer experience, in my opinion, when we have much more context, and we can formulate more analysis about how our web components interact with each other, like how the parts of our applications interact with each other. We have type systems that are much more advanced, at least for web development. I'm talking much more advanced than before. So we can also try to reduce issues and improve our understanding of the code base right there. So maybe it's just a matter, now we have like more advanced tools in the Node.js land or JavaScript land with respect to what we had 10 years ago. Maybe also people weren't really that comfortable with PHP, which was like the de facto language for web development right now. So they want to kind of mitigate the benefits of the evolution with the old benefits of server-side rendering from before. That's just an example of this cyclical evolution. And about microservices and like serverless, and people who used to keep their own in-house data center migrated to the cloud and then reverted back. Well, I think it's just a matter of market and like economies. I think if we hadn't we had the COVID pandemic and all the crisis that has impacted the tech sector, like it did in the past 2 years, in my opinion, we wouldn't have that many people trying to go back from cloud services to some sort of in-house solution. I think that choice is mostly dictated by budget cuts because of deploying your own application to the cloud is definitely more comfortable than having to maintain some infrastructure yourself. But it comes at a cost, of course. Like companies, like the big names. I don't want to name anyone, but the big names, who all know them, they have some margins, and those margins can be like very consistent.
Thanks.
So, yeah.
Hi, Rick.
Hi, I'm back again.
Great.
Yeah, well, I now joined you from my private computer. Obviously, my company computer can't cope with all the data load of this platform.
Welcome back.
I see. Yeah. So we just Alberto took all this time to talk about my first question. Okay, so if you want to continue, or I know that you didn't hear his answer, but we can continue the next one.
Yeah, let's go to the next one.
Okay. So Alberto, now it's your turn to ask the question. That's the way we're gonna do.
Okay. All right. So I want to ask a question to Rick. Like, with all your experience in tech, how would you say that testing, like, how did the approach to testing an application change throughout the years? And like, are you more familiar? Are you more comfortable with the testing tools and like practices we are currently adopting right now at a global level, or would you prefer to go back to a certain time where you had, like, I don't know, the perfect level of comfort with testing services? Like, how did this evolve in your opinion?
Well, the evolution of testing is quite interesting. There's two different kinds of evolution. One evolution is the profession of testing. So when I started in IT, the main goal of testing was find problems, fix them, and then we'll have perfect software. But a couple of years later, the great Jerry Weinberg wrote a book called Perfect Software and Other Illusions About Testing. So we'll never have perfect software. So testing is not about finding problems and fixing them. Testing is about getting information about the quality level so that we know if we have enough quality. Now, what I've seen over the years is two things, and that's mainly in the minds of managers. The average manager thinks testing can be done by anyone because anyone can just bang some keys and see if the system works. Well, that's only a very small part of testing. Because if you want to do proper testing, and for example, you want to know what kind of coverage you have, you need some more skills and tools and methods and techniques. And another thing is managers often think testing is too expensive. You know what? Let's automate it. Well, I always tell these managers, if you have a problem with testing and you buy a tool, you have two problems, both testing and the testing tool. So, and because implementing a testing tool in a proper way is quite a hard job. So therefore, I always say that people in teams, I like to have cross-functional teams with people with many different skills, because nobody is just only programmer or just only operations or just only testing. People have multiple skills, and they should collaborate to find the best mix to assure business value in their team. And so that's why today I rather like to talk about quality engineering and building quality in than to just talk about testing, because a lot of people think testing is something you do at the end. But if we build quality in from the start, you need much less testing at the end. And so, yeah, I always hope to inspire teams to spend more time on quality in the beginning. And then, yeah, tools. The fun thing with tools is tools are popping up every day. And some tools are great. Some tools are worthless. But don't think the tool will solve any problem.
Yeah, I absolutely agree with you about it. I want just to add that the testing tools, they are, or the entire ecosystem of the testing, doesn't make the huge evolution like the development ecosystem. Okay, it's everything much slower. Thanks God we have less testing frameworks than we have JavaScript frameworks. Okay, the JavaScript frameworks, they are like burning every week. We have a new JavaScript framework. At least on the testing ecosystem, we don't have this noise. Okay, but yeah, and this is the good part. But the opposite part of it is that I believe that if the amount of power or community, okay, that involved into the development and evolution of the development frameworks will be involved in the same amount of community in the testing frameworks, okay, we will have much better how it's called, testing experience, okay, or development testing experience. It can be much improved, okay. We can see it, by the way, on the if you remember, Petitier, and then we had PractiTest, and then we had on UI Cypress, and now we have Microsoft Playwright. We have Selenium. Thanks God, nobody not talking about it anymore. Okay, it's already like over.
Well, there is a new version of Selenium which is coming up now again.
Oh, really?
Oh my gosh. Oh my
Yeah.
gosh. Okay, I'm gonna hide myself somewhere. But yeah, so Selenium, I know the Selenium exists and it's used by Java and Python frameworks and stuff like that. But what I'm saying is this evolution can be much faster, and we might have better testing experience if we had, everyone will be interested in testing. What I'm saying is that not everyone, unfortunately, in the development world, are interested in testing itself. Okay, we have, let's face it, I worked for the 10 different companies lately, and in only one of them, when I started when I joined the project, we had some type of unit testing. Okay, all other didn't have any testing at all. So that's less or more, the percentage of the companies and the project that have testing in the world and did not. Yeah, this is.
Yeah, well, I'm still surprised that you come across people who don't do any testing, because the reason I'm surprised is when I was trained as a programmer, I did COBOL programming 42 years ago, and one of the first lessons is a program is not finished if there is no test with it. So I've been testing 42 years already, and now some developers tell me they don't need a test because they are brilliant programmers or they use brilliant frameworks, but still you can make mistakes. And so, yeah.
This by the way leads me to another problem, okay, with the the current way people learn development, okay, how they study the development. Back in that days, 10 years ago, 20 years ago, to study something, you had to read the book, at least, if you want to study by yourself, or to go to some courses. And then you had like formal teaching from 0 to 100, that's more, okay? Now, if you want to study something, okay, I want to be a front-end developer. Okay, so I'm gonna learn React, Angular, or Vue.js. Okay, because that's what everyone talk about. But what about the JavaScript itself? What about like how the code works? How
Like the
things?
preliminaries.
Yeah, how it's like basic, and that leads to the fact that there is a lot of developers who not only they're not talking about the tests or how to test themselves, how to write the quality code, they even don't know the language they're writing on this code.
Yeah.
Okay, so this is also the good and the bad part of the self-learning online courses and stuff like this, because you can actually take any course and say, hey, now I know how to develop the Angular. Sure, I'm not sure. Yeah, so that's also the problem. Rick, now it's your turn. Try to bring us back to the software architecture.
Yeah. Well, one of the things I often wonder is the confusion I often see when we use the word architecture, because some people think about enterprise architecture and others think about clean code architecture. And I've seen huge confusion because people say, yeah, let's talk about architecture. So my first question to you is, how do you cope with this confusion in your projects? How do you make sure that people are on the same page when talking about architecture?
It's a great question. Albert, you want to start?
Yeah, like usually when people talk about architecture, I'm thinking about the system and design of the applications and like the parts of the applications that interact with each other. Like you may have a set of services. These services might interact with one or more databases. There might be some need for other temporary services like spot-on instances, or like you might need to transfer a chunk of the data to some other processing machine and then maybe asynchronously retrieve it back in some sort of transform way. That's what I mean by what usually mean about architecture. I think the example of clean code per se mostly applies to monoliths, to maybe modular monoliths. At least that's my view there. But I think it's a little bit less interesting to talk about architecture in that sense. Like usually, what's the most complex part when you have like a complex system with several interacting parts, and you maybe it has been evolving for years and years, and few people have like a perfect understanding of how every part of the system works. Well, maybe that's where it really gets interesting and where you can really observe whether the initial choice or like the latest choice of the architecture was sufficient and adapt to the project scope. Because like you might think that you are introducing a way of scaling out the application, whereas on the other hand, you might risk creating a bottleneck somewhere else within the same context of the application. So yeah, that's what I'm referring to with architecture. How about you, Daniel?
Yeah. When we're talking about the architecture in the projects, it's first of all, it's I think the happiness of any developer or any architecture, it's to start a new project. Okay. The thing that can be better than that is to rewrite some project from scratch. When you have the product that works and you know what you need to get, it's already working, and you have plenty of time, people, and money to build in the correct way, with the correct architecture and stuff. Okay. It's happening a lot, especially with the startups, building the POC, then the POC become an MVP, then MVP become a production first release. Why? Because it's a startup, it's have to prove on each stage something as fast as possible, time to market, etc., etc., etc. Show me the money, and then after a year or two, they get into the situation when there is no architectures, this code is not maintainable, it's not testable, it's not scalable, it's have to be rewritten from scratch, because even there is people who wrote the initial code, they're not in the company anymore, and no one actually can take the responsibility and say, I know how to rewrite or I know how to refactor it. No, there's no way. You need to write it from scratch. And this actually, I love this project because you know where you need to get. Okay, you can see the final product that you need to be there. And all you need is just to make it the same product, but in much better way. And another thing that I like to say when I'm starting the new project, from scratch, the refactoring the project, is that if you want to become a big company, if you want to become an enterprise, and your product, you want it to become an enterprise, so start thinking as an enterprise right now, before you actually develop it, okay? I really do not like, it's all about the requirements. If someone asks, hey, I want to make some kind of, marketing website for my company, even if it's a huge company, but it's just marketing website, you're not going to build any architecture. You will say, hey, take WordPress and use it. Okay, that's it. Like, you're not going to, don't waste your money, don't waste your time. Just use WebStore. But if you build in the SaaS platform and say, no, let's make it fast. Okay, let's make it really fast, but let's release something. I will say, let's add 20% extra for the time, and we will at least have the architecture, if it's not 100% compatible with the enterprise level, but at least we can then easily to switch it to the enterprise level. Okay, so even if you develop in everything like on the small application, because you don't have time for the microservices, and manage all the DevOps around it, because microservices and now micro frontends, it's all make it all these things complicated. But think about the architecture as tomorrow you will actually split it, or you will try to scale it. You will go to the more enterprise level architecture. So build now your code that way that you will be it will be much less painful, to change it. This is my belief, and this is what I'm always trying to say to managers, sometimes successfully, sometimes less. It all depends on the number of developers, but yeah, any architecture, either it should be huge or small, it's all about the requirements. But always need to look at least 2-3 steps forward, meaning at least where you want to be in 1 or 2 years from now. If this is your target to be enterprise, so think about it from the day one. If it's not your target, if you build something, let's say, for example, I was working on some systems that are widely used by big companies, okay? And in each company, it was like 2 or 3 content managers who was using the system. It there's nothing about high scaling or anything like this, okay? In overall, we had like, 2,000 users for the system. Each one of these users is like huge companies, right? Enterprise and stuff like this, but there's nothing to talk about the micro frontends. Nobody don't need the scaling. Nobody don't need anything like this. It's all about the configuration system. It's not so scaled. That's it, okay? And that's enterprise product. Even then, you can say, okay, this is the enterprise, but I'm not going to have so many users, okay? So it's all about the use case specifically, and always need to think about the year or 2 or 3 where you want to see yourself, and how do you want to see your product in the future.
It's always a luxury, right? Having the ability of seeing in the future, having the ability of saying, okay, this product in 3 years, I expect it to be placed in this part, in this segment of the market, because especially if you're a startup, you're much more susceptible to rush changes dictated by the market, dictated by aggressive competition. So sometimes you really start with a carefully planned architecture, even though like after validating the first MVP. But what happens is that the strategy of the overall company changes throughout the time you are spending in development, right? Within that 3 or 2 years window. So what happens then? You end up with some sort of Frankenstein architecture, right? It has some parts that kind of fit the original purpose and just happen to magically fit the new goal of the application, and some other parts which can be painful to deal with, which might be a bottleneck, which might be overly complex, like overkill with respect to the current space of the current context of the application. So yeah, it's always nice when you kind of lay it out in some sort of theoretical book way. Like, but in practice, I think that there are so many variables, so many changes, even market changes, right? Because maybe, yeah, this company starts, you have a bunch of team working on separate service. Let's make this example, right? You have, I don't know, 5 different teams. Maybe they're working with their own tools. Maybe they have like in-house built libraries and frameworks and whatnot. And they have this sort of rather complex application growing up. Then at some point, a huge crisis happened, like it has already happened recently, and 4 of the teams get laid off. And suddenly you have a company which is much thinner. You have only 1 team, and then you have like a huge application to maintain. You lose visibility in the context of the other applications, and suddenly you kind of have to simplify things around if you really want to develop anything. And maybe that's when like you could have planned the most beautiful architecture, the most scalable system ever, but in practice, the reality often hits very hard, right? So to me, it's best to kind of keep a trade-off between good enough architecture and also add some flexibility, add some buffers to kind of allow you some wiggle room, right, to adapt.
Yeah, I agree that sometimes, we're not living in the ideal world, unfortunately, and sometimes the reality might hit anyone. Okay, by the way, it can hit also in the opposite way. You build, it was a small company, okay, you had a small team, you worked really, efficient, you had the architecture that was fitted exactly for the small team, and then you got investments, okay?
Mhm.
You got your, I don't know, $100 million of investment, and requirements from the investors to scale immediately to the big company, and you hire. I also had this once in my life, and you're hiring 60 people in 3 months. Okay, you build 4 development teams, 3 QA teams, and they're trying to manage all this and try to build all the architecture and rebuild all the architecture, and then you just spending sufficient amount of time on making the architecture to be workable for multiple teams, because everyone steps on each other toes, and it's all big mess. Okay, the Git merge is something that takes more time than to solve all the conflicts, takes more time than to develop the features. So yeah, it can work in both ways, by the way, definitely. Okay, and if there is a immediate change, either to scaling down or to scaling up the company, it's really might hurt. But it's not happened so often, fortunately.
Where I also often see a lot of trouble is if parts of the development are outsourced to another company. And then you get the problem that they are separate, and then obviously they just work according to one or another assignment, which is rather thin, and there's not much about the architecture in this whole agreement with the other company. And do you have experience how to cope with that?
So yeah, it happened, and usually what's really important is the initial communication. Like you kind of need to lay out the goals of the application. You need to really lay out your requirements, like not just I want this app to do this and that requirements, but also I want this app to be structured in a way that when my engineers get the product back, they're able to contribute back to it. They're able to properly understand the patterns used, or like try to evolve it independently from the original set of developers that had worked on that. So like the initial part of the clarifying this is very important, but also like you need to make sure that the people you delegate are good enough that they follow these requirements. Of course, you kind of need to check in on them, and sometimes it happens, sometimes it doesn't. I think it really depends on whether you're hiring agencies that are known for their careful planning and careful interaction with their clients versus other agencies maybe with less experience or like that don't really care about this project. They just want to get rid of it as fast as possible. So yeah, it all boils down to maybe their reputation, etc. But yeah, I get your problem. Whenever you delegate a core task to an external person, an external entity, you always have the risk of kind of disrupting the whole project, because also like there are risks that they might not be able to deliver on time, or if they do deliver, they might hide some problems, some latent problems under the hood that you only discover later on in development when you get back the project and have to like create something new on top of it. Because usually when you receive it back, everything is perfect, like everything looks polished. The demo usually goes fine, also because it's pre-recorded. And then you pay them. And I don't know, 1 month along the line, you discover that something is very broken, or like something is architectured in such a way that it cannot possibly reach your goals. So yeah, again, you acquire time, like you have a bargain in terms of time, because you could use your developers for something else, but you have an increased risk, and also like you have a decreased visibility on like the evolution of that project, because it can evolve on its own. You just give directives, but you didn't really see that evolving and see the intermediate steps. So yeah.
Yeah, what I see happening in the market now is that more and more organizations want to maintain a DevOps approach, and they don't just outsource the work, but they try to more co-source the development. So integrate the external DevOps teams with their own DevOps teams. And I think that's an interesting solution to this outsourcing problem. And 5 years ago, we could not have imagined that it would work. But since the pandemic, we have much better tools for online collaboration. And yeah, I think that's a good way to go and to solve the problems that you're describing. Daniel, what's your view?
I had a positive and a negative experience with the outsourced companies. And I agree with Alberto about the definition, the way how you work with the outsource. Besides, it's all about first of all, to make the research before you're selecting your outsource company. You're not running to the cheapest one or whatever. You go and you're selecting. You need to reference, you check the references and stuff. Similar like you hiring, in-house someone. You want to hire someone good, so same with the company's process. But even then, it's all about the expectations, in my opinion. Okay, it's always about the expectation. Even with the worker, it's about the expectation. Developer on management. Okay, even it's all about to close the expectations, and to actually to define the process when you as a company or you as a customer have a what's called holds your arm on the pulse, okay, and you actually see the incremental changes all the time, and you have the ability to test it and check it by yourself all the time, and you have actually milestones for the company. We had the bad experience that we had once, okay, is just we gave the entire project to the outsource company, and was expecting in a half year to get the application. Okay, after a year, the application was still crashed on the phones. Okay, we couldn't open it. So, and then we just changed everything. Okay, since there's some kind of politics, so we have the same company, but we changed the entire team. We hired the people. I was actually hiring developers for the team, building the teams, defining the flows, defining the workflows, defining with the product work, how it works from the product, milestones and everything, and then it starts working. Okay, when we actually split the entire project for the small pieces of milestones and say, that's what you should get. What is your estimations? What is your responsibilities? Like in 1 month, that's what we're gonna show us. Okay, and we'll check it and we'll recheck it, and it should be covered by test, etc., etc. Yeah, it requires, if it's a big project, if it's and you go doing it outside, you have to manage it, definitely. Okay, someone have to be on site, or someone have to be, consistently on the process, in the process with it, starting from the architecture. Okay, it's also something that have to be, of course, discussed way before the project starts. Okay, how it should look like, how it's architecture, monolith, microservices, technologies, language we had. It's one of the funniest thing. Okay, I just take it 30 seconds. Sorry. One of the keys that was highly important for us in terms of the product quality is end-to-end UI testing. Okay, and the product, we will write end-to-end UI testing. We talked about all technologies, the frameworks that should be used, JavaScript, TypeScript, React Native, everything. We talked about everything. The one thing that we never talked with the company is the way how they're gonna run the end-to-end UI tests. Okay, they said we're gonna don't worry. Okay, we didn't worry. And then appears it comes that they have their own UI testing framework written on how it's called, this language, the Jenkins is written on Groovy.
Oh yeah.
Okay, written on Groovy. And it's closed. It's not an open source or something or anything like this. Okay, it's internal source. So even if we wanted to take it out, we stay and left without any UI testing for the UI multi-platform mobile application. Something that actually highly, important for us. And that was one of the biggest mistakes that we did that time. Okay, to say, don't worry, we're gonna care about it. Okay, and then we're like, oh, it's not care. It's an anchor. We just stuck with you now just because of this UI framework.
Yeah.
Okay, now we need to pay you, even if we want to leave you, we still need to pay you for this UI framework. So yeah, this is also some of the things that need to be taken into consideration. Okay, so we don't have enough much time left. We have another 3 or 4 minutes. We didn't talk much about the software architecture.
Yeah, like I have a question about the data architecture in like modern application. Like we usually started back in the day with like one large database, maybe one Oracle instance, and then we shifted to maybe more spread out databases that were still traditional in some sense. Maybe you had like a bunch of Docker containers running Postgres here and there, or maybe you had Redis also, or like a caching databases. But now we have kind of a surge of much more specific kind of databases. Like we have time series, something just focused on time series, something just focused on analyzing streams of data. So I wonder, are you excited about this current state of software architecture, and are you scared that maybe it will develop in a way that it gets a little bit out of touch with reality, or like too complex for small and medium enterprises and only accessible to large enterprises? Or would you say that everyone could benefit from the current state of the art, where we can also like react to data in real time in those like various database instances?
Rick?
One of the big challenges in large organizations is that you have a lot of distributed data. So you have many different data sets and you want to connect them. And then you need clear view on architecture on how to use each other data, and also what kind of restrictions are there. Because I currently often see problems with people having too much possibility, so they can see more than they should, but it's very difficult to limit it, and that needs good architectural principles, and not just share the whole database, but make good proper views on it. Daniel, anything to add?
I'm not a big. Sorry, just let me make zoom. Oh, now it's good. If there is anything that I'm not a big, don't have a big experience on, is actually databases. I'm familiar with a lot of them and worked and built the different systems, but to go down deep, the only one thing that I can say about is that I think it's also I really hope it's going to have some circle history like other technologies that we talked about it. When we had the one database for everything, okay, then everyone, it was MySQL or Postgres or whatever, then everyone ran into the Mongo. Oh, we don't need to make any migrations. Let's move to Mongo. Everyone ran to Mongo, okay, and then this Elasticsearch. Let's move to Elasticsearch, and then they realize, okay, hold on, the Elasticsearch is only for searching. It's not for the updating data. Now we need to have two databases, okay, one to search, another one actually to have the data, okay, and sync between them. And then realize, and now we're realizing that, hold on, if I need to filtering or anything like this, I do need a relational database, RDS. So I will use probably RDS, and now I will, for some certain of data when it's relational, and I will use also the Elasticsearch for the free text search, and I also use the Mongo for the some additional data documents that might be changed or don't have any structure or anything like this. And now we have at least 3, 4, 5 different databases, data sources in our system. So I really hope that one day we will have some kind of single database that able to run and sync and have all these functionalities out of the box. And it's all will be, in terms of the configuration of the, I don't know, it's going to be table or collection or whatever it is, and you can use it accordingly to whatever you need, but it's going to be one technology, and you will need to know only one language to deal with it, and not to have it's all over. That's my hope about it. That's what I can say about the databases. Hopefully the circle will be closed. But databases, it's also one of the technologies that doesn't make a lot of changes during the time.
And one of the things that is now bringing many more challenges, that is AI and use of machine learning, where we feed lots of data into a machine learning model, and then we think that it does something useful. But it's a totally different ball game, and I see organizations struggling an awful lot with that, because it starts again with data architecture. What do you intend to do with your data? And some people think AI is magic. Well, I can tell you it's not. It's and if you have wrong data, you also have wrong AI. So
it's not a magic, but AI can be really helpful. Okay, you have this a lot of MEMS. The way how I work with the ChatGPT, write me a test. Just throw in the code, give me the unit test. That's it.
Okay, but before people think that ChatGPT can actually write proper tests, the reason that it works for you is that you know what kind of output to expect. So if ChatGPT gives you something, you can say, okay, this looks usable, I'll reuse it. But if you wouldn't have any knowledge, because ChatGPT makes quite a lot of mistakes also, and you have to be able to recognize what is correct and what is not.
Yeah, and that's also true for Copilot. Like, I generally use them for repetitive tasks. Like if I have to, they cannot spare me the time of coming up with a complex regex for like larger refactorings in a file or something, like renaming or all the existing methods or something according to a pattern. But like, or like to create a small unit tests for some functions, I don't really care that much. Then I can quickly see whether it's kind of making sense, whether it matches the rest. But I would encourage people not to overuse tools that much, because there's like a risk to kind of delegate so much that first of all you might risk losing a little bit of your focus and tools that you gather with experience if you always start delegating that. And then there's always a risk that the answer you receive, it seems so carefully crafted, but in a deceptive way. Like maybe there are like some large problems under the hood, which happened to me like while testing ChatGPT, etc., where I will get memory leaks, or I will get some cases in which some undefined behavior, maybe with low-level system, that if I had written the code myself and thought about it, I wouldn't have had in the first place, and only spotted that via writing tests on my own, or like via testing it out on my own. So that's something cool. But one part where it's very useful is, for instance, when you're integrating with databases. Like I'm one of the core contributors of Prisma, so we're working on database tooling for TypeScript engineers, basically. And to do that, we need to understand the catalog tables and kind of the metadata tables of Postgres, MySQL, etc. And I don't know if you ever looked at the documentation of those, but it's quite dense, right? There are so many subcases, there are so many things that can go wrong, and even databases that are like theoretically compatible, they actually have differences. So it's very useful to kind of ask ChatGPT to get an overview of like the structure of how do I retrieve the the indexes for this particular type for every table on MySQL. How do I retrieve that? And then you compare that with queries you previously had, maybe in this data management system, and you get errors, of course, and then you say, well, I need this MySQL version to be at least this one, at least 8 or something, and this table doesn't really exist. And then ChatGPT says, well, maybe, yeah, you're right, this was the right table. So you can get this some sort of interactive pattern, and I find the interaction quite useful. But again, I wouldn't trust it that much. It's always better to kind of have brainstorming with an actual person, in my opinion. This can be a useful tool, of course, a useful help, but I wouldn't solely rely on that. And encourage, like, especially people who are just starting in tech, to not give up human interaction entirely. Yeah.
Okay, so on this happy note, that actually let's finalize the human being is still better than ChatGPT. Let's finish our panel discussion. We run out of time. I have my own talk in 10 minutes from now, and I need to prepare. Thank you very much. Thank you, Alberto. Thank you, Rick. My name is Daniel.
This is all we got. Remember the revolution in our minds. This is all we got. Lock me out of this life institution. I am angry and high on illusions. Yes, I hate, but it's not a solution. Try my best, buddy, I'm just a human. Oh, we don't need to say we're sorry. We don't